I'm working here. Haha. But I'll check comments periodically, as I always do. Laszlo, I'm doing this project for him, and I went through all this trouble. I'm just kidding. I did this design, which I thought was very structural, very very cool. Right? It's got support for this infill wall, all this stuff. Well, it's going to be more expensive than what Laszlo wanted to do. So what we are going to do is change it to just a wall that sits on top. And I'm going to explain how I'm going to do that. But first we're going to attach this 4x4 around the edges. The reason I'm going to use a 4x4 first is because the tops of these containers are not very conducive to. You see, you're probably going to have to notch out a little bit of the edge of this 4x4. Okay, so we want to do all that and get it fastened down good with these straps, bar straps, where you can weld this part to the container or tack screw it like I've got it here, and then run a lag bolt into the 4x4 to hold it, to strap it all down, because this will be inspected, and I can promise you the building inspector is going to raise an eyebrow about this if you don't do enough. You know, the danger is that the building inspector will ask you to get an engineered drawing, an engineered stamped drawing, and you will have to that's going to cost you more money than what I'm charging you. So what I'm going to do is set this line in a 1/2 inch. What I meant to do was make that a group so I can delete it later. This is going to be my wall framing line. Okay, I want to make that a group. And so what I'm going to do is use my Medic extension. See if we have anybody saying hello. Hey Richard, how's it going? I'm going to use my Medic extension, Medic wall extension, and I think I'm going to make this wall 4 feet 4. Well, let me do something first. I'm gonna bring over these two columns right here. And because even though I'm not going to build those walls the way I show it on that one, I still want these two posts here, and they're just they will be fastened down to the concrete with one of these Simpson post bases. Okay, and then you'll have some angle iron here, some 4-inch long angle that you can just weld to the container and bolt down to the concrete. The reason I brought those over was because I wanted to see how tall they were, how tall my wall's going to be. 4 feet 4 and 3/16. I think I just want to make it 4 feet 4, and that's what I was going to do. So I'm going to make this, I'm going to put this down. Oops. Why is that? I'm going to let this go down 3/16. And I don't know if I made that a component or not, so I'm going to measure to see if it went down. It did. I'm smart, aren't I? So those are that post is a component, and now I can make this wall. Let's see. What I want to do is I've got this beam. Where is it? That I'm going to leave on the front. Where's my LVLs? My LVL. Here we go. I'm going to create a sort of a portal frame here. But what that's going to require me to do is, that's right, these two walls on either side will be shorter than the walls on the sides. So I need to measure, well, they'll be 4 feet 4. So what I'm going to do is, I'm going to bring the wall, and I'm going to make it 4 feet 4, which is 52 inches. And I'm going to make it out of, I don't know what the header height is yet. That doesn't matter. It's going to be 2x4s. And 16 inches on center. Let's see. Can I get by with 2 foot on center with this? I think we probably can. Laszlo would probably, let's see. Yeah, because our trusses are going to be on 24-inch centers. And then stud direction left. I think that's right. Let's see. I think what I'm going to do is I don't want to use a California corner. Those are outlawed in Tennessee. I'm just kidding. I want to use a 3 stud block. Actually, for this, let's do a 3 stud solid. 3 stud solid, because it's a short wall, doesn't really matter. 3 stud solid. And let's just, I think all I'm going to do is wall sheeting, but I'm not going to do any kind of siding. Wall sheeting material. I don't want to do any chipboard. So let's just see what we got here. I want to start this. Yeah, that's right. I offset that wall a 1/2 inch because I just want my sheeting. Dang it. Why did it do that? See, this is the thing. Oh, I didn't update it. Dang it. 52 inches. Let's update that to begin with. That's the length. Oopsie. The height is 52 inches. Let's do that. Let's get that. Let's get rid of this siding. Wall cladding. No. Update. And let's turn on the wall sheeting. Why is my wall sheeting? Okay, close. Let's go over here to wall sheeting. Turn it on. There we go. I want to make sure that that's going to work. Yeah, I want that to be flush. I want my, and that's supposed to be, I didn't update, what happened is I didn't update any of this information. I changed it, but I didn't click update. So now I'm going to go back in here, say 24, and we want it to be 2x4s. 3.5. Update that. There we go. And I can get by on this one. I just need a single top plate. Can I do that? Top plate 1 on this one. Okay. So you see, that's just a little infill wall. really. Now the corners, I want that to be stud solid. Update. Why is my end? Let's try inside out inset outside terminal. What's that mean? Well, I'll just have to draw my corners, which is no big deal. I'm trying to use this extension. I'm trying to get highly familiar with it. Now that's going to be that wall, but now what I want to do is I want to measure, and I'm leaving this LVL long for right now. I want to measure from here to the top of the LVL, because this wall will be that height. (5'1" and 7/16. That would be 61 and 7/16. So let's go down here and we'll start our wall extension again. Let's see if we have any comments. Good, but a lot of rain here and still look for, oh man, I'm praying for you, Richard. I know how it is. We just have one house we're building right now, and we're about finished with it. And we got another one to start, but I can't get the foundation in because the foundation guys are so far behind. Wall. Okay, we're going to make this wall. We're going to start off with 5'1". So we're going to make it 61 for now. That says, oh wait. 61, and we're going to do it out of 2x4s, 24 inches on center, because my trusses are going to be on 24-inch centers, and I want that to all stack up nice and neat. And then bottom plate, we want two top plates on this one, and let's go to, I don't want this wall cladding. No. Wall sheeting's fine, but I don't want any. Okay, so let's update that this time. I won't make that mistake again. Now I'm going to go all the way down here, and I'm going to run it to this point right here. There we go. And we'll see how our corner did. It did a California corner because I did not tell it not to. The stinking California corners are driving me nuts. 3 studs solid. Update. And why is that not updating? Oh, because I don't have the wall selected. Three studs solid. I need to go in and just change that in the programming so it can't do it ever again. Three studs solid. Update. There we go. That's what I want it to do. And why did this wall cut itself back that far? That's odd. It's really odd. I think what I'm going to do is I'm going to have to, I'll fix that. But that's kind of the way I want. What I was going to do is use the extension just to get most of the wall drawn, and then I'm going to fix it. But I wanted to see what height this wall needed to be. It needs to be, oh, it's the 7/16. Well, I can't do 7/16, can I? I'll have to put it in. Oh yeah, I can. 7. Let's see. We'll put 11 and 7/16. Update. I didn't think I could. It says feet and inches. But it's not letting me do. I ran into this one time before. Oh, that's the wall. Oh my gosh. Oh my gosh. That's the wall length. Oh, why do I keep doing this? No, that's right. 47 feet 11. This is supposed to be, oh, that's what it is. The height, I have to do in inches. So I want to do 7/16. I'll have to do, I really don't want to, what I might do is just lower this razor, lower this beam. I think that's what I'm going to do. Because I really don't want to do some weird height on the wall. When I start dimensioning all this, I really just want to have a height that makes sense. And so I may just make this 62 inches. And then I'm going to adjust the beam. Oops. I'm going to make the beam that height. And why is that? Oh, that's an optical illusion. I'm going to fix that plate. But then I'll have to fix these. Yeah, this right here. And that's a component, so this one over here should have brought itself up. And it did get. Now all I have to do is bring this beam if I can get out of this edit mode I'm in. I'm just going to push this whole thing back, and then I'll fix the other. A lot of this will become obvious, I think, soon enough. I'm going to fix that one down there when I get to it. But what I'm going to do is, I'm actually going to start from here now. Now that I know how tall this wall is, I was just kind of playing around with the heights of this. That's 5'2". Okay. And I'm going to start right here because I got my little offset dimension. Our wall, we wanted to make it 62 inches. One thing that confuses me is this top thing changes to wall length after I build the wall. It changes to wall length instead of wall height, and I keep going into that to change the length. I mean the height. It's really the length. So now I want to do. I don't know why these 3-stud solid. It just occurred to me I might have. Update. Okay, so we're going to go from here all the way down to here, and then I'm just going to go ahead and turn the corner. And that's really what this extension is designed to do, is just to keep going. There we go, and you hit space when you're done, the space bar. And why is that? Again, what am I doing? Is this not 62 inches? 5'2". I know I told it 62 inches. Am I going crazy? Oh, somebody probably said, no, you said 40 or 50, 42. But that's what's nice about the extension. I can fix it. Uh, 62. Update. There we go. Now we should have a nice. There we go. See, 3-stud corners just look nice. That's what they look like. You know, they're just nice and neat, and none of this weirdness you get with a California corner. And this, I bet, did I say 4-stud corner on this? Is that why it's so bulky, or is it the 3-stud solid? Aha. 3-stud solid. That's why it looks that way. Yeah, okay. I thought so. I wondered why there were so many 2x4s in the corner. There. Now I can fix this. Let's see. You know what I meant to do is make this wall 3.5 inches shorter. Well, you know what? When I run it this way, it will be. And this wall is, let me measure this wall. Forgot what it was. 4 feet 4, okay. So when I run this wall into that, I hope it fixes that. 4 feet 4 wall. I love this extension by Medique. Oh, it defaulted to 4 feet 4. And 2x4s. I want one on this. I just want one top plate because it's going up against that beam. And I want 3 studs solid. 3 studs solid. Update. And we will go from my little line I got here over to here, and this should set that wall back. Let's see what it does. Yeah. But that's supposed to be, this should be 3.5 inches. Oh, that's weird. My LVLs aren't the right thickness. They should be 3 inches and 3/4. But I'm going to fix that right now. So this should be 1/4 wider. And that should move over a 1/2 inch. Well, to here. And then this should be 1 and 3/4. 1 and 3/4. I'm just going to delete this one and copy this one. Oh, and that's supposed to be 3.5 inches. Yep. And then what I should have done was made this a component, and I could have really what I want to do is like that, but this wall for some reason this taller. Let's see what happened here. Don't understand that. Did I lose time here somehow? What happened to this was up here. Does that make my... What does that make me off the... He wanted 14 feet. I feel like I'm getting taller and taller every time. Yeah, 14 and 9. Yeah. I don't know why. See if I got any questions. Maybe my brain just needs a break. No, you put 52. Yeah, I know. That's funny. Hey, Tony, have you ever worked up a design for putting a Quonset hut on shipping containers? No. That's an interesting idea, though. I've done a Quonset. Have you seen my metal building? I have done a Quonset hut, though. That's an interesting idea. If you... Oh, should I get into that? Let me show you. I'll just show you right quick. I think I did that under this Metal Pro Buildings. Metal Pro Buildings. Metal Pro Buildings. Just the model. Here we go. Save, yes. This is the one I did for Metal Pro Buildings, and I actually did the animation work for it. This is their Model J, I think it's E1620 or something. So that's one of their Quonset models. But that's interesting. You could that's not a bad idea, actually. I don't know if you're still here. Sorry, I'll try to keep up with the comments better. I'm trying to figure out what I want this all to be. I think I should just keep this simple and keep it 14 feet. I hate having these weird dimensions. Yeah, I think I want to drop this 9/16, this beam. Which is probably back down. And I don't know why it's sticking out. What did I do? It should be flush. Oh, I know what it is. This should be out here. Oh, that's why. Okay. That's why my wall wasn't perfectly flush on the inside. I get it. I want to go there. I want that to be the same height. Now I just got to make this other wall that same height. But that's where I was before. So I can't have my cake and eat it too, because, well, that's actually wrong to say it that way. You can't eat your cake and have it too. You can have your cake and eat it too. You just can't eat your cake and have it too. So I either got to have a weird dimension for this post or a weird dimension for this wall. So which would it be? Let's vote on it. Do we make this 14 foot and 9/16 and we'll just claim it's 14 feet and then have this wall just be a nice even dimension? Or do I go ahead and try to shrink this wall down? That 9/16, I don't like that. I'd almost rather leave this ambiguous and just claim it's 14 feet. What do y'all think? Y'all left me. You left me. I think I'd rather be able to tell Laszlo just to build this wall a certain height. That, you know, I think I'd rather just tell him build it 5 foot. What if I said 5 foot? Or does it matter? This is where you can get atrophy right here, worrying about this stuff. Which one do you agree? You make it even. What do you mean? The two choices are this. Right now, I've got this at a nice 14 feet, and I'm measuring off the top of these footings because, see, it's 14 feet. Because this is where he's going to fill in. He'll fill this in with gravel. So my measurement is from the concrete pier, the footing. So I got that 14 feet, right? But that means that this wall can't be a nice 50, 62 inches. It would have to be 5 foot 1 7/16. I don't like that. I almost feel like raising this beam back up and making this, but see, I guess either way I gotta have this wall. It would be a weird dimension. So just bring the top of the beam up. Yeah, I think I'm gonna do that because I don't like this, and I'll just have these two little weird walls. And what I'll do is I'll tell him, you just gotta build those walls up to meet the beam. So what is it actually? I wonder. Yeah, there's a space there. We don't want that. Is it really 3/4? Well, that's not a big deal. Wall height, 52.75. There. Done. Good suggestion. $52.75. Update. There we go. Now, the reason I'm doing this is because this building, and I'm going to delete this. I'm going to delete that now because that setback was to get my OSB flush with my 4x4. I don't want the OSB sticking out. I wanted it to be flush with it. So, what I'm trying to do here is create a situation where, and now I can bring this OSB up. I'm trying to develop once I do this, I can't edit the wall anymore. Once I bring this up, I can't, which is okay. I'm done done with the extension now, I can just start working on individual building components now. And I'm going to explain this. And I'm going to cheat. I'm going to draw a little line across here just for now. Did I get that? Yeah. Oh, I didn't, did I? I missed it. I don't know. Sometimes you can't. There we go. Then I'm going to move that down to there. Now I'm going to pull this across. I know that's at least, let's see, it's 40 minus 8. I know it's at least 30 feet. Let's go over and see. Oh, way too far. We'll go back. To here. Now, what I'm doing is creating like a portal frame situation where this, and I'm going to draw, I'll separate this. I'll go back and do all this other, all this other stuff, all this detail stuff later. I'm just trying to show Laszlo really what I want to do here. But on these openings, on these big openings like this, you have a problem bracing the building, okay? Laterally, like this, okay? So what you do is you run your header, this is called portal framing, okay? You run your header past the opening, like if we weren't concerned with if we weren't concerned with bracing this wall, the header would just stop right here, right? And this wall would just come on up, and it would be jacks and all that stuff, okay? But what I'm going to do is run this header all the way, and then what you can do is put a nailing pattern on your OSB into that header. Boom, 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 boom. You know, and what happens is it creates a lateral brace in this direction. Does that make sense? Do y'all know what portal framing is? It's you can look it up, but basically if you have like a garage door that's close to the edge of your house like this, if this was the corner and this was your garage door opening, you would have to let the header pass all the way to, oh come on JLC, come on now, I'm already registered, dude, good lord. Oh, yes. No, go away. I promise I'll come back. Anyway, let's try something that's not going to spam me right off the bat. Oh, here we go with the journal again. Anyway, you see how the header runs past the opening when normally it would just be right here, cut right. This OSB now is going to go and lap over that header. Oh my God. Okay, I'm out of here. Sorry. This OSB laps over that header, and you can nail the heck out of it 3 inches on center. And what it'll do is it'll create a nice corner. Okay? And your building inspector is not going to be fussing about this. He's going to be fussing about you building on top of these containers anyway. What you're trying to do is convince him that you're a good person, okay? Now, just trying to be a little funny there. Now, now we're going to stack our trusses. I hope this is going to work out, because if it's not, I can fix it. We are going to start our trusses here. And I forgot what pitch this is. You see, I had all this figured out, and Laszlo said my design was too expensive, which I thought was mean. But I think he's right. I had these walls going all the way down, right? And I was going to be able to brace. I was going to put clips on these containers at these posts, and it was going to brace the building off laterally, right? So it wouldn't just be sitting up here on top of the thing. And I'm just kidding, Laszlo, if you're watching. Laszlo is supposed to watch this later. What is that, 312? 312. Okay, I just wanted to check. Let's get rid of that line. But I got to start a new roof because this one's not going to be as wide as that one. Okay. Now it should be. If I was smart, I would go ahead and show my bracing because I think I'm going to show some more bracing in here, just so because I'm afraid the building inspector is going to ask Laszlo for a stamp drawing on this, but we're going to try to get him around it because he's just going to use this for storage, and it's not for human habitation. Now this is Medique's truss extension, and it's awesome. Okay, we're going to pick this corner. We're going to go down here because I used to literally draw trusses by hand. What I would do is I would call my truss company and get the design from them, and then I would use their design. Pitch, we want a 312 overhang. We're going to do 24 inches because it's a big old roof and it's going to look funny if you don't have at least a 24-inch overhang. Say okay. And gabling trusses, yes. And advanced, let's say yes. But I'm gonna turn off. Let's see. I want to turn off the cladding, yeah, for right now. And outlookers, yes. Optional soffit cut. Let's see. Roof sheeting, yes. Subfascia, yes. Board, yes. Let's just say for now we'll get our trusses and our OSB on there. Let's see. And then we'll turn off the wall sheeting for right now so we can see our trusses. Isn't that awesome? And the other reason I put this header across here, well, is because now he has this nice, when he puts his ceiling in here, if he does put ceiling and material in here, I doubt he will, but if he does, he'll be able to end that there, and he won't have this weird situation where the ceiling material just comes all the way out to the end of the wall. You'll have that header. Then in the future, if he decides to put a door on here, he'll already have his opening ready to go. See if we have any other questions. Just bring the beam up, okay? So that's the dealio with the, now one thing I like about Medique's, I'm sorry, about SketchUp's 2021 version is we can create these folders now, and you can see I have a foundation folder, a floor folder, a wall folder, roof folder, site, structural, and Medique creates all these all these tags, layers, but I can just grab them and put them in the wall folder and then close that back up. See, and it just kind of helps. That's probably an empty one, yeah. And what is this? That is probably, yeah. And this 4x4 bearing, we'll put that in the wall. There. Now I have a nice, neat structure here. Now, if I want to turn off the roof, all I got to do is hit that button. It's kind of nice because all the layers that are in the roof now, I can control with just, it's more like a file management system. But what I was going to do here is come back in now and check my framing, and I don't want this. I'm going to explode these walls now, because if I don't, if I regenerate them, this will go back. I want this cut back to here, so it's going to be butt into my beam. And now this is weird. I don't know why it did this, but I'll have to figure that out. Now, the thing is, over here, I like how this wall, I like how this is done. I like the beam going all the way like that. So what I'm going to do is I'm going to cut this wall back, and we will fix that. I'm going to explode this wall. Let's see. And I'm going to move this over. Now I'm not going to need, now this wall, .5. Now this wall will have the corners on it. Thought I was editing. I should have grabbed it on that side. There we go. Like that, and then like that, because if I turn my beam back on, where is my, what happened to my LVL? Oh, that's in the roof. I want that to be in the wall layer. I want to be able to control that up here. Oh, shoot. Let's go back up here, and did I put it in there? What happened to it? Oh, losing my mind here. Where is my LVL? I'm losing it. Right there it is. What layer did it say? Wall, post, and beam. What in the world? Somehow my beam got put in a different layer. That was bizarre. And I didn't do that. It renamed it. It right before your eyes, you saw it. All right, so that's fine. If I turn off this roof now, okay. Yeah, it used to be called beam LVL or something like that. But that's what I want right there. Now I want the beam though to come out to the end of the wall, so I'm not sure why that happened. I'm going to pull it out here, and I'm going to go look at the other end. And I'm going to get rid of that line because it didn't work. This is tidying up my framing. There we go. Now what I'm going to do is turn on my trusses. Let's check my corners. this corner should be, honestly, and this is one thing I need to talk to him about on this extension. Your two long walls should have the corners on them, but what he does is as you go around, the corner gets put, see, on the next side. And this one is right. This long wall, we would frame the two long walls first, and then the short wall would go in between it. But I'm not going to get that angle right now with it. But the reason is because you lay these two walls out the same, because those are the walls your trusses are bearing on, and you want your layout to make sure, you want your layout to be the same. You see, so if I need to explode this wall too. If I get rid of this for a sec, oh Jesus. I hit the page down button. Let me turn off the wall sheeting. Somebody needs to take that delete button and move it away from the page. What is that? Page up, page down, whatever that is. Did I get this? Yeah. So this corner should be, and I know I'm not complaining because, I mean, heck, the extension saves me a lot of work. But these walls, there's a practice here that I want to teach people, and the practice is that your bearing walls, your two long bearing walls, should be laid out exactly the same. Okay, you don't build the walls going around in a circle, okay, or around the perimeter. They're built to be exactly the same. Now, is this 2 feet here? Yeah. And the other point is that this would be back here, and where are we? This would be back there, and this would be here. And I could have done all this on one wall at a time, but I'm trying to show it. That would be lapped over that way. And that's the proper way to do it. And then the end stud, you see this end, the short wall doesn't have any corners in it. You see, it's just a stud on each end of the wall. That's the proper way. Right there. That's it. You see? Now both of these walls mirror each other. Right? So when you do your layout, they should be exactly the same. Okay. So now I'm going to turn on the trusses, and I'm going to check to see. Okay, I didn't want all that to come on, but it's okay. Metal roof, roof cladding, engineering. I want the roof sheeting to go away for a second, but I want the trusses to come back on. Aha, did we get lucky? We did get lucky, because see, we want our trusses, and this is the point, you want your trusses to be stacked right over your studs. Okay, that takes that load and takes it straight down. Now, I've talked to these hurricane ties, these Rafter ties don't go, and I've talked to him about this before. They don't go on the outside of the wall. I think I've talked to him. I've sent him an email. These go on the inside, and I'll show you in a minute. But I don't want to mess with them yet because I want to see what my outlookers look like. My lookouts. For some reason, he calls these outlooks in the extension, but we call them lookouts in construction. So I don't know. I'm not complaining again. He saves me a lot of time. Trusses. Let's see. Edit roof truss assembly. We should have structural outlooks outlooker spacing. Yes, we want them to be vertical, and they don't have to be on 24-inch centers, but that's okay. Do them on about 3 feet. But if you on these vertical structural outlookers, you can use them for the soffit blocking too. They kill two birds with one stone. Let's just fix that for a second, and I'll show you what that's going to do. I need to turn on the roof framing. There we go. What that does is you'll have your truss manufacturer build a dropped truss for your gable end truss. Okay, let's see if I can get where it looks. It'll be a dropped, what we call a dropped truss, and they drop it so that these 3.5-inch lookouts can come and hang out. You see, now these are cantilevered, and they're very strong this way. They're nailed flush with this one, and they cantilever over that gable end truss, and they hang out there, and I can tell you it's not sticking out 24 inches, I don't think. Why is it not 24? There we go. On a building this size, you got to look at the scale of it, and a 24-inch overhang just looks better. Plus, it'll protect your stuff better. You see, now we got all of our gable end truss studs lined up this way. We got all of our, let's see, are we offset 1.5 inches on this side? Now this is what I was talking about. You see how this layout, that's exactly what I was talking about, guys. You see how the layout's 1.5 inches off? Let me go. Apologies if you covered that. What did you say? Does he want to use the roof of the storage containers for stuff? He's gonna store stuff up there, but I told him, you're only good for about 300 pounds per square foot on these containers. I've done a little research on that over the past few months, and what we're gonna do is we're gonna go inside, and we're gonna every 10 feet we're gonna put a post to help support this roof, because I told him I didn't feel comfortable putting this big roof on here. Now, before I explode this roof, I'm going to make sure I got everything the way I want it. As a matter of fact, no, I'm not going to. I'm just going to go ahead and explode it. And the reason I'm doing that is because I don't like these hurricane ties, these rafter ties. Go on the inside of the wall. They don't go. Imagine yourself. Now, imagine this pitch being like a 12-12 or 8-12 or 10-12. That rafter tail would be hanging down at a steep angle. You can't get under there to nail it, okay? Besides that, the building inspector is going to look for them on the inside. And thankfully, he's got these just as components. So I just it's easy to fix, okay? These rafter ties go on the inside of your wall, not the outside. See, now your ceiling is flat, right? Or even if it's vaulted, you can get to it to nail it. Okay. Now, this is not really the rafter tie I use for this kind of thing, but it's okay. I use the top that looks twisted. It would be easy to change since it's a component. You see this top right here, these are the top I use. And they meet the code just as well as this one. As a matter of fact, I'll show you, since this is easy to fix, I'll just go in here and delete these. You can see the other trusses fixing themselves because they're components. Let's see, rafter tie. And I know they have a Simpson in here that I like. This is it right here. I like this one. See, and what you do, you just flip it around. Let's see. It's well, you flip it. Let's see. I flipped it the wrong way. Let me start over. For some reason, I always have to do this. I have to turn it and mirror it, and I have to do it every time. That's funny. There we go. Like that's how it goes. And yeah, you just have to nail them through the metal. You just gotta do it. It's just part of it. It's not that big a deal though. That metal, these gussets are not that thick, and the nail goes right through them. You see now all of my. Why is that not? Oh, I didn't put it in the cut. Go in and edit my truss and then paste it. See, now all my trusses have it. That's the type I like right there. Like that. And I'm going to take... Now if we go over to this side, the other one will probably... Let's import that again. And see if it'll work this time. In real life, these things, you just flip them around. It's only in CAD drawings that they give you a hard time. You see what I mean? There we go. I just had to flip it 180 degrees. And yeah, I didn't think I was anywhere near. Get over there. Get right there. Get down there. Right there. Bring it down a little bit. Again, in real life, these are easier to put on. Like that. Now, I bet I have to, yeah, for some reason, I'm not in the truss again. I thought I was, for editing it. Paste in place. Now we've all got, now, enough of that mess. But you see, that's those are acceptable too. So what I was going to bring up here is this. You see, because that I had to fix that wall. You notice that the studs are all, they're not perfectly straight across. So what I'm going to do is I'm going to select them all. Let's see if I can do this without having to pick every, oops. That was weird. So I can go in here and pick all of them. If I get past this wall, I can get most of them. Now, I've just got to make sure they're stacked. Of course, this is what we would do in real life. They just need to be stacked under the trusses. And it just goes to the point I was making earlier that these two walls need to be laid out perfectly the same. and they are built first. Your two long walls are built first. Your studs line up, and then this wall doesn't have any corners on it. It butts in. See, it butts into these two longer walls. See if we got any questions. No, I hadn't covered that. I covered it with the owner because when we were talking about the difference between this design over here, where I have all the load, see all the load over here comes down to the footings of the roof, and that's what I wanted. I couldn't get what I wanted because it was going to be more expensive, and I get that. I like to value engineer where I can. But you got to be able to convince. It's funny how it's funny how codes work. People think that just because you have a building code, the building code is a minimum standard. Okay, it's not the be all end all. Okay, so when you come up on a building inspector and you got this framed up and you're like, I want a framing inspection, and he comes out, he's like, okay, tell me how many pounds per linear foot this little 2-inch angle, because that's all it is on the top of a shipping container, a little 2-inch angle that the walls and the roof are welded to. All the loading, all the structural part of a container is down here on the floor. The floor carries the load, and the corners carry the load. The roof, when you stack two containers on top of each other, there's actually a gap between the roof and the floor of the other one. So it's only intended to carry the load of, weather. And so the point there is that what I'll do is I'm going to go in, and every 10 feet we will put probably every 10 feet will probably convince the building inspector, that we're transferring the load down to this. Yeah, I know why I said 10 feet, because I've got these footings on 10 feet. So the load would come straight down inside the container, have a post. You could put two 2x4s together or have a 4x4 and come down and have that load transferred. And that will probably suffice. Now on the bracing on this roof, you'll have a purlin. I'm going to draw it, but it's going to take a while. Let's see, I might already have, do I have bracing? Yeah, I brought some bracing over from another job, and let's see. I'm going to have to fix it. It's all out of whack. But you'll have, I'm going to turn that off too. It's going to bug me. You'll have, your bracing at the top here, those blocks you saw between the trusses, those are put on as you raise the trusses up and install them. And then you'll have a purlin on top of this bottom cord that runs the full length. And on a building this wide, you'll have 3 of them. You'll have one over here going all the way back, one in the middle going all the way back, and one over here going all the way back. But when you order your trusses, the truss manufacturer will send you a truss drawing, and it will show you where the bracing, there will be instructions from them on how to brace the trusses off. And so if we turn our wall sheeting back on, and our roof sheeting, we'll have something like that. Now, what in real life, this will probably, like, you would have 4x8 sheets that you would just run vertically, and I'll probably go back and fix this where it would be 48 inches wide, and it looks like, yeah, an 8-foot sheet seal will go all the way up. Yeah. So that would make the corner really strong if that whole corner was one sheet. And so you wouldn't, the reason I'm saying it is because you wouldn't have this situation where you'd have this skinny piece across here like that. And I'm going to fix that. So, oh, the other thing is I got to do is halfway down. Let's turn off our sheeting again for a second. Let's actually just turn off the roof and our wall sheeting. What the code doesn't allow these really long walls that are unbraced. Okay, you have to have what's called shear walls. Now, why did those are supposed to be in with the trusses? I'll fix that later. Those Rafter ties are supposed to be in with the. Let's see what they're tagged as. Untagged. Let's call it. I think it's that MPC. I think this is the roof. I think that's it. Yeah, that's it. Yeah. So what you have to do is you have to come here halfway, since this is 48 feet, and you can't have more than 30 feet unbraced. What they're talking about is shear. Imagine if you were standing on top of this container and you grab the top of that wall, you'd be able to shake it violently back and forth, right? Almost probably tear it off the building. If you were down here in the corner, you wouldn't be able to do that. So what we have to do is we have to come 24 feet in the middle. We're going to build us a little. As a matter of fact, I'm just going to use those other little walls. Well, no, I'm not, because they're not the right height. I said 24 feet. I thought I said 24 inches. Did 24 feet. And we're going to put us a wall here. Now, it's going to be a little bit weird because, and I talked to, how are we going to do this? I talked to Laszlo about this, and he likes the wall idea. What did we make that? 62 inches. So, and it'll have to have OSB on at least one side. So what we'll do, oh, that's right though. That wall will have to go from the top of the container. Not sure, actually a wall is the best. It might be that we just run a brace. The building inspector might, since this is not for human habitation, might let us get by with running a brace from here down to this corner of the. I want to try that, because you see, it's not going to do any good to set a wall on top of this if you can't connect it well. And it might be that all we need to do is have an angled brace, like something you would have while you were framing it, but it would just be permanent. I'm going to copy this, and I'm going to just kind of angle it a little bit, I'm going to guess. And I'm going to put this, get over there, get right there, and I'm going to run it out. Well, since this is going to be permanent, I'm going to go ahead, let me get it lined up first. What I'm trying to do is get this point right here lined up with, where is that? Is that right? I should have just brought it down first so I wouldn't have to guess. Kinda. Yeah, and then we'll have to figure out a way to I could get that down there to go like that. Yeah, it worked. And then we'll have to come up with a metal bracket. And probably, you know what we could do? We could probably double it and make the building inspector feel better. But what I want to do here, dang it, what I wanted to do was bring this out for, I should have brought this out to here, because what I wanted to do is have it so we could nail it or lag it. Couldn't get my reference point there. That was weird. Like that. And then I'll have to go back down here and fix. Well, dang it. It's short now. Dang it. And that means that it's going to be cockeyed too, because I got to change this angle. But I want this to look convincing. So I'm gonna put a little time and make sure it looks right. I want that to be right there. If I can get by with that same angle. Not supposed to, am I? That's kind of cheating, isn't it? Oh, well, we'll cheat a little bit. And yeah, because that brought that heel back. That's really getting anal now, isn't it? There we go. I wouldn't be able to sleep tonight if I didn't change that. So then I can, I think to be able to bolt this the way I want to bolt it, I'm going to double it. And then when you see, because then I can put an L bracket, some kind of bracket here, and I can run a longer bolt and it'll make me feel like I'm doing a good job. And then this one will just be like that. And you can nail them together good. And get rid of this. Oh, I'm going to use that as a reference. Yeah. So now what I'm going to do is I'm going to make this a group, and then I'm going to make it a component, because what I'm going to do is if I have to change this, if he doesn't want it a wall, I can just build a wall on one side and it will fix the other side. Oops. Which stud are we going to do over here? That's the same. Well, that makes sense. The same one. There we go. Like that. And then we'll have our metal bracket. But that way, if he says, no, I want to build a wall here, then, but I think this will suffice, because, and then what I want to do is, I really kind of want to, even though we're using OSB, I really kind of wanted to put braces all the way around this thing, but on this design over the other design, we were just going to put 2x4s horizontally and then put the metal siding over it. I talked him into using OSB on this one because it'll be a lot stronger as far as bracing the building. Roof trusses. There we go. Roof sheeting. There we go. And I want to get rid of this. I'm going to fix this whole sheeting here. Back looks a little better. Any questions? No questions? Y'all been kind of boring. I know one thing I need to fix. This roof. Oh shoot. See, I screwed up. I can't fix this roof, can I? Ah. Dang it. I meant to make this, well, on this size building. You know what? This roof looks better. Yeah. I was going to change the fascia and the barge rafter out here to 2x4s so you could use 1x6 fascia. But I think on this side of the building it's kind of large. That probably looks better. The scale of that looks better. Alright, well, are there any questions? What's the use of the building? Okay, good question. He's going to park. He's got several pieces of equipment, like maybe a skid steer or a backhoe or something that parks in here, and then he's going to put, store materials up here on top, and of course, obviously he'll be able to store things inside the containers. I had a guy did another one of these type things for it. Had barn doors on it. The guy was actually driving his skid steer into the container, and he was using this for something else. So I thought that was kind of cool. But yeah, it's I always tend to design these things to where they're for you could live in them, but that way the code issues are taken care of. But really, the building officials are going to look at this differently since it's just for storage. Usually they will. And let's see, what else was I going to do? What I want to do is, what time is it? 3:47. The market closes in 15 minutes. I'm going to text. Are y'all on Robinhood? Getting your GameStop stock crashed for you? What's the use of the building? All right, well, I think I'll end it here. I've been on here. How long have we been going? A little while. And unless anybody has any more questions, if this was on a farm, it would be great for hay, straw. Yeah, you know what? That's an excellent point, because you got your little lofts up there. You can stack a bunch of hay all the way around the edges. Have yourself a little ladder. I know he wants to. What he's going to do eventually is he's going to extend these roofs out on either side, this roof out on each side, and there'll be columns and beams over here, and he'll have wood racks, because he's got a bunch of wood he's got to air dry. And one of the reasons I was doing this way was because he told me that early on, and if it was me, I'd use these 2x6 studs to build the racks off of. And he liked that idea. He just didn't want to pay. He thought, obviously this is more expensive. I still like this design better. Laszlo. I'm just kidding. But I'm saving this one for somebody who wants to spend the money on it. This one will be less expensive, obviously, but again, you got to convince the building inspector that, well, what I'll do, and this is what I'm gonna come back and do this a little bit later. I'm gonna come in here, if you're just joining, and underneath these studs every 10 feet, I'm gonna put a double stud inside the container going from the floor up to the ceiling, and then that'll probably, I'm thinking, convince the building inspector that you're transferring this load down to these footings, which is really what he's probably going to want to know. Because the problem is, it doesn't matter what you think. It doesn't matter what your opinion is or what the internet says, how strong this is. All that matters is, can you show the engineering on it? And until somebody pays an engineer $1,000 to sit down for a day or whatever, 2 hours, and say, yeah, this container, and then they're going to have to say, well, this container made in China by this manufacturer. You can't just say every container. That's why it gets iffy, because now the building inspector is going to say, well, what container? I want to see the drawings. I want to see the stamp drawings. And they have every right to do this, okay? Because if this was a house, and you were putting this roof on here, you got people sleeping in these things. You got to be able to, prove that you're taking care of public safety. So, and that's their job. So, the best thing to do is design these things in a way that they're reasonable, right? And then you can tell the building inspector, look, I got my portal framing, I got my beam going all the way across, and I'm stuck in the roof. The beam goes all the way across. That's the other one. And I've got my OSB nailed to it. I got lateral bracing because of my OSB. I got this bracing in here. I'm making an effort here, Mr. Building Inspector, and he's probably going to say, okay, whatever. And I've got my double studs every 10 foot on the inside. But if you do something wanky, like I've seen a lot of people do on the internet, and they just go out and they start putting posts on top of these angles, they're going to question you unless you're out in a rural area that doesn't have to, doesn't require building inspection. The small top bales, yeah. I know what you're talking about. The type we would buy at Ace Hardware or anywhere. I guess they're what? Are they 3 feet long and a couple of feet square, something like that? What is the size of a small bale? But yeah, this 8 feet, so you can get them stacked depending on how you turn them. Bunch of, and that would be a good use for this, something like that. But you're talking about, a roof like this, 1,500 to 2,000 pounds per linear feet. You just do the math. So, anyway, anybody else? I'm going to end it here, and then I'm going to do some work later, but I have to run over to the job site right quick, and I'll be back later. Thanks, guys. Thanks for watching. I appreciate it. I appreciate the conversation while I'm working. That's why I do these, because I'm just working on this drawing, and it's a lot of fun to be able to have a conversation while I'm doing it. See ya.